Hello everyone. In this video we are going to discuss about problem on continuous and discrete time power signals. In the previous video we discussed problems on energy signal, and in this video we are going to discuss problems on the power signal. And here we are having a problem: determine the average power of the square wave shown in figure. Okay, and this is the signal x of t, which starts at 0 and ends at infinity, and it is going on. Okay, there is no end for this signal. It is keep on going with a amplitude of plus 1 for some cycles and minus 1 at some parts. Okay, let us solve this problem. In a continuous time signal, periodic signals, here we can see this signal is periodic for a t is equal to 2. Okay, this is one cycle, and second cycle starts at t, and the same signal repeats after one full cycle. Therefore 0 t and again at 2t. Okay, the cycle is repeating at a time interval t. Okay, now in a continuous time periodic signal, the average power is defined for only one full cycle. Remember, in a continuous time periodic signal, the average power is defined for only one full cycle, and here one full cycle is from starts at 0 here and ends at t, and the second cycle starts at t, which means we are having one full cycle from 0 to capital T. Okay, here in this problem, one cycle is from 0 to capital T, you can see. Okay, and if you want to represent mathematically this one full cycle, mathematical representation of this x of t for one full cycle is like x of t is equal to, the value of x of t is plus 1 between, the value of x of t is plus 1 between 0 to t by 2. Here we can see 1 until t by 2, 0 to t by 2. Okay, and the value of x of t is minus 1. Minus 1 starts at t by 2 and ends at capital T. Remember, we are representing x of t for one full cycle, that is from 0 to capital T only. Okay, now we got the mathematical representation of the signal x of t for one full cycle 0 to t. Now as we all know, power signal for a continuous time signal is given by P is equal to 1 divided by T integration of minus T by 2 to plus T by 2 x square of T into dt is the equation. And now for this problem, x of t varies between 0 to t, right? The duration varies from 0 to t. Therefore 1 by t integration of 0 to capital T x square of t into dt. Now since the signal is splitted for 0 to t by 2 and 0 to capital T, we can split the integration from 0 to t by 2 and from 0 to t. Okay, we'll be having two values. Splitting the limits of the integration 1 by t within the bracket integration of 0 to first limit is t by 2, the value of x of t from 0 to t by 2, the value of x of t is 1. Therefore I am going to substitute the value x of t as 1 square 1 x square of t, therefore x of t is 1 and square is taken from there into dt plus integration of second limit is t by 2 to capital T. As we know, from 0 to capital T, the value of x of t is minus 1. Therefore minus 1 square is there into dt. Now we got the integral. On solving 1 divided by t, 1 square is 1, integration of 1 with respect to t is t with limit 0 to t by 2 plus minus 1 square is plus 1, integration of 1 with respect to dt is again t for the limit t by 2 to capital T. Therefore 1 by t, applying the limits, t upper limit is t by 2 minus lower limit is 0 plus upper limit is capital T minus lower limit is t by 2. On resolving 1 by t, t by 2 plus 0, we are neglecting the 0 part, plus t plus into minus is minus t by 2. T by 2, t by 2 get cancelled. We'll be left with 1 by 2, 1 by t. Within the bracket we are having t. T get cancelled. Therefore the answer is 1. Therefore the power, the average power for the given square wave is 1. Hope you people got the steps. Okay, moving on to the next problem. Check whether the signal is energy or power signal. Also find the corresponding value. Okay, we need to check whether the signal is energy or power signal, then we need to find the corresponding value. And the problem is x of n is equal to cos pi n for n greater than or equal to 0, which means n greater than or equal to 0 means n starts at 0 and ends at infinity, and x of n is equal to 0 otherwise. Okay, now this is the signal. To solve this problem, remember x of n means we are talking about a discrete time signal here. They given from looking at the constraints of this problem for n greater than or equal to 0 and otherwise, we can say the given signal x of n is of infinite length. Here we can see n is greater than or equal to 0 and it keeps on going. There is no limit, upper limit for this one. Okay, which means it is of infinite length. Okay, hence we cannot calculate energy of an infinite length. the signal is of infinite length, we cannot calculate the energy for an infinite length signal. Okay, therefore it is an power signal. Therefore it is a power signal. And for power signal we need to find the sample. Okay, to get the sample, how we are going to find the sample, I will just explain. Before that, we need to define the power signal first, right? We know power signal for a discrete time will be P is equal to 1 divided by capital N summation of n is equal to 0 to capital N minus 1, okay, x of n whole square. This is the equation, and here the sample n is unknown. Again, as I said in the previous problem itself, the power signal, the average power is always calculated for one full cycle, remember, and here it is a here it is a cos wave. You can say cos 0 is 1, cos pi by 2 is 0, right? Cos pi by 2 is 0, and cos pi is minus 1, and cos 3 pi by 2 is again 0, and cos 2 pi is plus 1, right? You all know the values. Cos 0 is 1, cos pi by 2 is 0, cos pi is minus 1, and cos 2 pi is plus 1. And here we can see the signal is repeating, the amplitude 1 is repeating after the interval of 2, sample of 2, one full cycle, and after this one complete of one full cycle the signal will be repeating. Okay, here this is what we can see here. This is the one full cycle. Cos 0 is 1, cos pi by 2 is 0, cos pi is minus 1. Okay, the amplitude 1 is repeating after a sample of n is equal to 2. Therefore the value of n is equal to 2. Okay, substituting the value here, we will be getting p is equal to 1 divided by n is now 2, summation of n is equal to 0 to 2 minus 1. N is equal to 2, 2 minus 1 is 1, x of n is nothing but cos pi n whole square. Okay, this is what the signal is now. Now we got p is equal to 1 by 2 summation of n is equal to 0 to 2, sorry, 0 to 1, cos pi n whole square, right? 1 by 2 summation of n is equal to 0 to 1 cos pi n whole square. Okay, substituting n is equal to 0 and n is equal to 1, you can split it, adding cos pi into value of n is 0 whole square plus cos pi into, now the value of n is equal to 1 whole square. We are just expanding the summation 1. N varies from 0 to 1. Okay, 1 by 2, pi into 0 is 0, cos 0 is 1, 1 square plus cos pi into 1 is pi into 1 is pi, cos pi is, as we marked here, cos pi is minus 1, cos pi is minus 1 whole square. Now we got 1 by 2, 1 square is 1 plus minus 1 square is 1, 1 by 2 into 1 plus 1 is 2, 2 to get cancelled, we'll be left with 1. The average power, the discrete time signal x of n is equal to cos pi n for n greater than or equal to 0 is 1. Okay. Hope you people got the problem. If you have any doubts, please do put a message on my comment box. We'll be connected. Thank you.